Hello, everyone. I hope you can hear us here from GlycoSpot loud and clear. So I'd like to welcome you all to this afternoon or mornings, depend on where you're sitting, of course, webinar that we have entitled "The Power of a Fast and Accurate Malt QC." First of all, I am Jonas Jacobsen, Commercial Director in GlycoSpot, and with me here today I have Raimon, and Raimon will take us through the scientific part of the presentation. I think I'll just introduce with a few words. We are a Danish-based biotech company, and we have specialized into developing application-based test methods for enzymes. And we have done that because we truly think that it's possible to transform the way many companies, many universities are working with enzymes today. So with our, let's say, in-depth understanding of the application, we develop assays that are fast to implement and easy to use, and I think that is, for many people and many labs around the world, can make a difference. The industries we work with today is the malt and brewing industry, the distilleries, and we're also looking into industrial cleaning and CIP cleaning processes. So I think with that, I'm maybe half a minute from now, I'm gonna let it over to you, Raymond, to take us through the webinar. Raymond is our malt specialist and senior scientist here at GlycoSpot. And you're going to cover 4 topics today. And the first one is the value of understanding knowing more about your malt quality today. And the second topic is on the importance of enzymes during germination. And then you have how to leverage from a fast and cheap malt QC. And finally, you have some stories on how GlycoSpot has brought this into the world or has helped others already. During the presentation, should you have any questions, you can ask questions in the right side panel. I think we're gonna save the questions towards to the end of the presentation unless something acute pops up. So I'm gonna track the questions that come in, and we'll try to save them for the final discussion. With that, the word is yours, Raymond, so take it away. Thank you.
Thank you, Jonas, for the nice introduction. Now I'll share some slides with you all. And you should be able to see them now. And so good afternoon, everyone. As Jonas was mentioning, we're gonna go through a presentation called The Power of a Fast and Accurate QC for Malt. The agenda for today was pretty much presented by Jonas, but basically we're gonna cover, besides the introduction, we're gonna cover what is the GlycoSpot method for malt in general. Then we're gonna go a bit deeper when it comes to monitoring amylases during germination. Also, we're gonna see the tools that we have for measuring enzymatic activity in malt extracts. And also, as Jonas was saying, by the end of the presentation, we will also cover some questions and answers you might have. A bit about ourselves, that was done as well by Jonas, but as I said, I'm the senior scientist in charge of malt, but also brewing applications, and we are also covering distillers. And together with Jonas, we also have other 14 employees, which cover a broad range of specialties, from digital marketing all the way to chemical engineers, in which we have one focus, which is develop and commercialize enzymatic assays. When it comes to us as a company, GlycoSpot, or what I can say, I've been a couple of years working here, and it's a very healthy work atmosphere. It's a company that has all the necessary equipment and facilities to perform the development, but also the commercialization. And of course, we also like to spend time building or team building with our colleagues. We, of course, love to eat cake like everybody else, but we also try to have a good collaboration between us. Now let's jump directly into the first scientific topic of today, which is the use of our method, the use of GlycoSpot method for malt. And to do that, let's have a look first at the value chain of beer production. So from cereals, in this case barley here to beer production at the end. When you have barley, you have starch, but you need something else to produce the sugars that afterwards will be converted into the alcohol and into the sugar or carbohydrate profile of the beer. And what you need is actually enzymes. So to promote the production of these enzymes, what you do is the malting process, which basically consists in 3 steps: steeping, germination, and kilning. Steeping, in which the grains get soaked in water. That promotes the growth of the grains into the new plant. You can appreciate some roots, and I'll go back to this a bit later. But basically, in this step, right after the steeping, in the germination, in which is the preparation of the grains to become the new plant, is where the enzymes become active. And among these enzymes, we find the amylases, which are the ones that actually convert the starch present in the barley into sugars. The last step is the kilning, which is a heating process. And once you kill the cereals, what you get is the finalized malt, the malt that brewers can buy on the market. This malt is then milled and mixed with hot water in the brew house, and that's what is called the mashing step, or sometimes it's also called conversion step, in which the enzymes present in the malt convert the starch into sugars. I'll go back a bit later into this with a bit more detail. But for now, we would like to present you what it is, the GlycoSpot method. And for that, we also need to see where do these enzymes that I was mentioning before act. So when we talk about amylases, we have alpha amylase, we have beta amylase, but we also have other compounds. But when it comes to amylases relevant for malt houses and brew houses, perhaps alpha and beta amylase are the most relevant because they are the ones that become more active during the brewing. Currently, most malt producers, they do analyze the activity of these 2 enzymes, and they have several ways to do it. They have EBC or ASBC methods, which are generally time-consuming and require a bit of labor work. There's also enzymatic assays, but that require a lot of preparation, a lot of chemical handling, sometimes hazardous chemicals. And then there's a third option to actually send your samples to a specialized lab to perform either EBC, ASBC method, or also enzymatic assays. In this regard, we are different because we offer a product that is easy, quick, and ready to use, but that can also be done in the proximity of the production. The range of products that we can actually measure with our kits are several, but we focus mostly on alpha and beta amylase for malt, and that includes barley malt for the, you can say, regular range, which is normally 200 to 400, but in a more extensive way from 30 to 500 British Cobalt when it comes to diastatic power, and 10 to 100 dextrizing units when it comes to alpha amylase. We can also measure this both alpha and beta amylase for high diastatic power malt, which is malt above 500 British Cobalt. The same kits can also be used with malt, And we also offer products for malt extract, and that is to measure residual activity when you produce this malt extract. I'm going to get back to malt extract a bit later today. But for now, let's have a look at the simplicity of our method, which is really the core value of what we are offering. So in or with GlycoSpot method, malt consumers and malt suppliers are able to measure enzymatic activity in 20 minutes. That is from mill malt to the result. And that can be done simultaneously for up to 6 samples. That could represent an enormous time saving for most of the malt houses. The steps that include the method include the weighing of the malt, 200 milligrams, and extraction for 10 minutes with a buffer that we supply. After this 10 minutes extraction with buffer, there is a syringe filtration. We also supply all the plasticware, including the syringe and the filter. After that, the GlycoSpot method consists of incubating 250 microliters of this extract and incubate it 7 minutes at 35 degrees. After this incubation, the only missing step is to actually measure on our own spectrophotometer series, which is a handheld spectrophotometer, which is also connected to an app which you can download in your own smartphone, and measure right away the activity of the sample that you weighed out here. To understand the accuracy of our method, what I show here is a compilation of different ring trial results in which we participated. This includes samples from MAPS, which is managed by LGC, IFBM, VLB, but also other companies. What you can see in these results is that our method, which is shown in the gray bars, is able to hit the values of the samples measured in the ring trial with the EBC methods, with an accuracy of plus minus 20 vintage callback. Plus minus 20 vintage callback is well below the reproducibility criteria that is fixated by EBC Analytica, which follows this formula, which for this range is between 50 and plus minus 50 to 80 vintage callback. So we are well below or well within the reproducibility criteria by EBC. When it comes to repeatability, what we can see, and we measure these samples in triplicates, is that we are also between the limits of repeatability, which in this case, for this range of 200 to 450 vintage callback, that would be between plus minus between 15 to 20, 25 vintage callback, and we are able to hit this range. That was for normal diastatic power. When it comes to high diastatic power malt, what we did, we got some samples from a supplier, and we measured, or we send them to a lab to be measured using the EBC method. What we could see is that there was no correlation, but then we compared the results from the specialized lab that used, again, the EBC method, and we use our own GlycoSpot method. What we could see is that we could correlate perfectly with the specialized lab result. So we are actually able to measure with a good accuracy also for high diastatic power. And I'll come back to these discrepancies when it comes to samples from suppliers. Because if we think about the malt supply nowadays, they are very, you can say, mature processes. They have been working for decades. But of course, there's many different batches that are produced every year by every single malt house, and one can expect that issues can happen in the production. So for instance, there could be cases in which the different batches of the malt production have no enzymatic activity, or there could be some other issues like inhomogeneities across the different delivery, or if, for instance, there is a seasonal variation from one year to another year, or it could be that even within the same harvest there is variation. And also it could be that several batches mixed in the same silo could present variability from the top of the silo to the bottom of the silo, for instance. We had one case in which the variability of the same delivery by the malt house would have a significant difference from one part of the delivery to the can say the beginning or the first malt you would collect from a shipping to the final part, which would be in one case 9% below what was stated in the certificate of analysis supplied to the customer, but in another case it was 24% lower. So there was actually a considerable difference from one part of the batch to the other part of the, you can say, delivery. Now let's hear one real case, one testimonial from Avant-Garde Malls. Probably most of you know who Avant-Garde Malls is. We're talking about the biggest malt producer in Germany. They produce above 300,000 tons a year. And last year they tried our kits for a few weeks. And after this trial period, they were so happy that they decided to adopt our method. Quoting directly the quality director, Winfred Manke, which maybe some of you know, he said, the values obtained by using the GlycoSpot method were in the range of plus minus 5 Bindishkova, which is better than the repeatability R95 as given by Analytica EBC. He also added, we have decided to use this method in our routine laboratory. As the method is easy to handle, rapid and precise, we will replace the existing method and we will also enhance the frequency of analytical checks. So now, after this testimonial from Avant-Garde, I'd like you to present our results when it comes to monitoring amylases during germination. Here you can see a small picture of green malt, which is malt that has its ongoing germination during the malting. But let's start first with a small introduction when it comes to germination. So basically, this is the structure of a, you can say, germinating barley grain. You can see the roots that we saw in the previous picture. So basically, in the grain, there is mostly three main parts we need to take into account. There is the embryo, there is the, what we would call the endosperm, and then we have the aleuron. Okay, so the aleuron is where the enzymes are produced during the germination. The embryo is the part that sends gibberellic acid, which triggers the production of these enzymes into the aleuron. And then we have the endosperm, which is actually where the starch is consumed, but is also where the enzymes need to migrate in. And at the same time is where the beta-glucanases and silanases in this case need to break down cell wall material that you find in this endosperm. After the germination is completed, what you find is what you call a modified endosperm. That is an endosperm with low content of cell wall material because it's degraded by the enzymes. But most importantly, what you find is alpha amylase that has migrated into the endosperm, but also beta amylase that is originally present in the cereal and that has been let free by the action of the proteases. So beta amylase is bound to the protein content of the malt, but then the proteases release them and allow them to be active during the mashing or during the use of the malt. In this graph here, you can see the result that we produced by using our method. In this case, we're talking about alpha amylase. And as you can see, by running a germination at room temperature, we have a sudden increase after 15 hours. That is consistent with what you can see in literature. And what you can also see is that it's accurate enough when we compare the values with what we can see in the literature. So this method that we developed for green malt can be used for malt houses or for anybody who's actually using green malt who wants to verify the activity or who wants to optimize the malting process. Now, when it comes to green malt, we also need to consider that it is a growing topic. There is recent publications from 2020, but also from 2021, in which there are experiments of brewing beer with green malt. We are very aware that distillers might be using green malt nowadays, but it's not yet very common to brew with green malt. The reason being that sometimes malt needs to travel thousands of kilometers and green malt is not the most stable product. However, it is a growing topic. There are research publications that has been released recently. There's also commercial patents that cover green malt used during brewing by big breweries, big brewing groups. At the same time, there are logical or some benefits of using green malt that tap well into the current trends of sustainability. For instance, if you don't kiln your malt or if you use a lower kiln, what you can do is use less water when you brew the beer, but you also use less energy because you don't need to dry the malt. At the same time, because the enzyme activity is higher, you lose some enzyme activity when you kiln the cereals, when you kiln the malt, sorry. Then you can also take advantage of the higher enzymatic activity of the malt. Now let's have a look at our methods for malt extract. Malt extract, for those who don't know, is a syrup produced by making a mashing process with malt and evaporating the water so as to produce a kind of syrup, resembles honey, smells very malty. When we talk about malt extract, we're talking about a commodity that is used in many different areas, also in beer production to add flavor, but also when it comes to products of mainstream food like cereals, bread, cookies, but also milkshakes and chocolate shakes. However, in many of these applications, there is a requirement that the enzyme activity of these extracts is low or low enough so as not to disturb the production of the food product that you are entailing. So for instance, if you have a too high amylase content, you would disturb the bread production, just to give an example. At GlycoSpot, we using the same concept that I presented before, a simple method, we were actually able to detect very low amylase activity present in malt extracts. And in this real example here, from one of our customers, what we can see is that we were able to measure well below a 1% of the initial activity of the malt. That's the threshold that our customer told us to use. And what we can see is that the enzyme that we can detect is around 20 times below this threshold. We can, of course, customize this for the threshold that you are willing to check, but our method is accurate enough to go well down when it comes to enzymatic activity. So summing up for today, with our method, what we want is to provide the malting sector with a tool to measure the amylase activity, and the end goal or the value is to be able to quality control all the malt batches or supplies by using a method which is faster, which is simple, which is reliable. At the same time, we want to help maltsters or those customers who want to measure during germination, and at the same time to verify if the residual, or to measure the residual activity when it comes to malt extract. If you are curious to try our method, or if you would like to see if this is for you, we have a very interesting program of a 30-day free demo in which you will have in your hands the possibility to use our spectrophotometer series together with a heating box. For details, I would ask you to contact us. This is my email, and this is Jonas' email. We will be very glad to enter into discussion. But we already have several customers who are interested in this promotion. So from here, I would say thank you very much for your attention, and we would be very pleased to answer any questions you might have. And here again, you have my email and Jonas' email. Yeah, Jonas, I think this is back to you now.
Thank you, Raymond, and thanks for a great presentation. I actually have quite a number of questions coming in here.
Okay.
No surprise with the group of people listening in today. I'm just trying to get an overview and see if I can group some of the questions. But I think the first one we can ask like this. So it's a combination of two questions. The first question is, does your method for diastatic power for barley malt work without any further internal validation? And I think it ties nicely together with another question, which is if we can elaborate on what we mean by fast to implement. Can you put some words on that, Raymond?
Yes. I would say that from our experiences with different customers, that it doesn't take a long time for them to implement the method. In most cases, before you can say 4th, 5th sample, they were able to hit the values. Of course, the first time you try a new method, there's a lot of new information, but it took less than 4 or 5 samples for the customers to actually try or validate the new method. They had some internal values, but at GlycoSpot we also have some reference samples we can supply in case they need to have such a validation.
I think if I can add, Raymond, that's actually really a part of the offering from our side is that we try to take away as much as possible the implementation and validation phase by having run a very extensive data set, ensuring that in all the corners of barley malt we still have a high accuracy of our test method. So I think it's you need to rely on the data that we put in front of you, to, let's say, including data from ring trials, for instance, that shows the high accuracy compared to other test methods and other labs. So
yes.
there is There's another question here. What is the difference in the assay for high diastatic power malt compared to normal diastatic power malt and wheat malt?
The main difference, it's very simple. It's a higher dilution level when it comes to the extraction phase. So basically, the assay looks the same. The customer almost feel no difference between one and the other. The steps are exactly the same.
I think another question here, almost what we could expect, because we are currently frequently asked this question by our customers, and that is the method certified by EBC? And I don't know if you want to say something there, Raymond.
We are in the process of getting EBC certified. We're seeking for it. What we can say is that we got some letter of intent of our customers to pursue that. We also, I guess we can mention that for one of the ring trials, maybe I cannot mention which one of them, but one of the main ring trials will also include the name of our method explicitly in the ring trials that they will perform from now on.
I think if I can just correct you, Raymond, sorry, we are not in the direct process of having EBC as such is not certifying test methods, but we are taking part in the different ring trials with the LGC VLB on reference samples where our test method can be so to say benchmarked against the EBC standard, and that's where we deliver the high accuracy. But as such, there's not a possibility to get a certification by EBC. Let's say the appraisal or recognition you would get through some of the lab running these or organizing these ring trials on reference samples.
It's worth mentioning that it's because they don't certify methods that belong to a company. They certify general methods.
One more question here. Well, how can I get started with a demo period?
Contact us, I would say, right, Jonas? That would be the best way to start it up, and we will give a fast reply in the same day.
Yeah, and I think you already showed some email addresses. We're also going to share a link to the presentation here and also an email where you can reach out. Otherwise, you can find us, of course, on our webpage. I think just two more questions, also technical questions for you, Raymond, here. Can the test kit be used with non-germinated cereal like barley?
We tried with barley and it worked fine. So actually, we can assist in that. It's the same assay. It works the same way. Please contact us if you are in doubt, but it does work with non-germinated cereals.
How does the app work and what information is in the app, calibrations, etc.? That's a good question, I think, actually. Can you put some technical words to that, Raymond?
Yeah, so basically the app is what you see is a front end, but of course behind the app there is a hard work of calibration so that the measurement that you see in the spectrophotometer is displayed in the units of your choice. That could be Windisch Kolbe, but it could be also Lindner or IOP for diastatic power, dextronizing units, Sir-alpha units, international units for the other. We have a whole list of units. If you're in doubt, you're of course very welcome to contact us. But basically the app shows the enzymatic activity that you are measuring in the screen of the phone.
Thanks, Raymond. I think actually one last question just popped up on my screen at least. Let me just see what it was. Yeah, I think, here it is. Why should we choose the GlycoSpot method over our current method?
Well, from my side, I'll say the technically wise, it's very simple to run and it's very fast to run, and it's also doesn't require a long training or the use of hazardous chemicals. These are the technical advantages when it comes to the GlycoSpot method. As I said before, you can run up to 6 samples in 20 minutes. That's really fast, I would say.
Excellent. Thanks a lot, Raymond. I think that is it for today. Thank you very much to everyone listening out there. As I said, we're gonna share the presentation, or link to the presentation with all of you, and you're obviously more than welcome to reach out, and you'll get a let's say a follow-up greeting from GlycoSpot in the coming time, and we can try to connect over the possibility to run some or even more demo trials with the potential future customers. Thanks a lot.
Thank you very much. It was a pleasure.
Bye. And stop.